students. When you have a problem like this, the first thing that you want to do is visualize the sample space and also remind yourself what the sample space is. Traditionally, we call the sample space omega, which is sort of like the Greek W. And the way I like to think about this is that the sample space is the set of possible worlds. In each world, each variable that we're talking about has a distinct value. And so we can look at, for instance, all of the worlds where x equals x0 for some x0. And we can break the sample space up based on the value of x. So we have all of the worlds corresponding to x equals x0. We have all of the worlds corresponding to x equals x1, and so on to x equals x m. Well, they're discrete random variables, not necessarily finite. So this could go on forever. But that doesn't really change much. The important thing is that there is a set with the important thing is that we can count them. Now similarly, we can break the sample space up corresponding to the different values for y. Y equals y0, y1, and so on. Those are pretty bad lines, but the great thing about math is that your pictures don't have to be pretty. And we write mathematically like a row of this as, all of the worlds, the set of all worlds, such that x of the world, because x is a function from worlds to the possible values for x, equals little x. And we write a little square as omega in big omega, such that x of omega equals x and y of omega equals little y. And now you can see from the picture that this set is the disjoint union over all of the y values of this set, just because the row is made up of all of the little squares. Every single world in the row has a distinct y value, and so that means that the worlds in the row are broken up into the sets corresponding to all of those possible distinct y values. Now we have this formula here, and we can apply to it. So this is a equation of sets, and we want an equation of numbers. So we have to apply the probability measure to these sets. And the third law of probability allows us to do that. The third law of probability states that the probability assigned to this set is the sum of the probability assigned to these sets. So we can write that P x equals little x equals sum for y and sy, probability that big X equals little x, and probability that big Y equals little y. And we're done. This is the problem, because that's the probability mass function for x, and this is the joint probability mass function for x and y. Thank you.